Okay, here comes the sunrise. Um, I wanted to start that a little sooner, but I had a bit of trouble getting it started. Hopefully, hopefully everything's recording okay. Um, this is the International Space Station. For those who don't recognize it, or if I maybe didn't title it well, I'm I'm recording the video right now, of course, while I'm talking, so I haven't actually written a title yet. I haven't even decided what the title exactly is going to say. But I'm recording a screen image from the um, live stream of the International Space Station, and I'm not certain, but I think the uh, changes in brightness are probably are well, possibly the camera trying to adjust for the different amounts of light. I don't know if they have if they have that set to automatic, or what the case might be. It might be something in the atmosphere, something to do with the way that the light is reaching the space station. Might be a good question for somebody who would know better than I would. But it's interesting to watch nonetheless. And the sunsets and the sunrises look different because of the direction the camera's facing. You won't actually see the sun in this image, um, but you should see the Earth. It's not there. It's not showing yet. Um, but oh, there, way up near the top. If you look, there's a little blue streak that's showing up on the top left. That is a bit of light showing up on the horizon of the Earth. And as as the International Space Station continues to orbit toward the lit side, or into the sunlit area, that light will expand. It takes about 92 minutes for the International Space Station to make one orbit around the planet. That falls a little bit short of orbiting back to over the same piece of land, because the planet actually also rotates a little during that time. 90 minutes is roughly 1,500 miles or so. So, so during that time, this position on the ground that it would have ended up back over, or that it started over at the beginning of that orbit, has moved on by some 1,500 miles or so. There you can see a little more of the land getting lit. Again, I'm not exactly sure why the brightness goes up and down the way it does, but the thing is, the sun is actually very far away. So this is why, from the angle that it's showing, you can see that the sunlight is actually coming from the left, and so as the space station got around to the point where the sun was no longer blocked by the Earth, where the shadow of the Earth was no longer directly on the space station, then of course the space station gets lit, and the sun would be up, basically off the top of the screen at that point, and rather quickly has moved quite a bit to the left. Of course, you can't see it because that's out of frame. But in the as the space station goes around, the sun, of course, it's not the sun that's moving; it's the space station that's moving with relation to the Earth and the sun. And so as it goes along, that light will go from toward the upper left side of the screen to where it's eventually coming as if the light's going into the screen, and by that point the ground underneath the space station, the ground on the Earth underneath the space station will be quite well lit. So it's not that hard to go on the International Space Station's live stream page um, and actually see this for yourself while a sunrise or a sunset is going on. But I figured for those who don't want to spend the time waiting for that, or don't want to, have to try to figure out exactly when that's going to be, I'd go ahead and see if I could film this and make a video of it. So I'm hoping that my commentary on it will make the video somewhat more interesting, although I haven't made a script or anything, so it's not like I had anything planned exactly to say. Um, I just figured otherwise all you're going to hear is like static, because that's what's coming through the live stream right now. There's no actual like people talking or anything interesting on there. So you got me. Of course, they could come on there and say something at any time. I doubt they will while I'm doing this, but yeah, it could take me by surprise. Um, Anyway, you can see now the dark area is way down toward the bottom, and if you look at the shadows, you can see, as I was saying earlier, that it's moving away from sort of up and to the left, and actually rotating around um, again, because the space shuttle is, you see the planet appears to be moving in the background. Yes, the planet's moving, but it's not going that fast. What you're actually seeing is 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 the space station going around the planet, not the planet rotating under the space station. Since the camera's mounted on the space station, it's easy to uh, think of it as looking like it's the planet rotating, but the planet doesn't rotate fast enough that you can see it rotate. I mean, it's an indetectable amount to the human eye. It's just imperceptible. At well, I mean, obviously, if you were close enough to see the ground going by you and you weren't rotating with it, yeah, that would be different. But if you were standing back where you could see the whole planet, yeah, depending, if you're close enough that it takes up your whole field of view, yeah, you'd see it was rotating. But if you're back where it's like holding a basketball out at arm's length or something, you'd have to look really carefully to see that motion, because it's very, very slow. It's literally 1 degree every 4 minutes. So you're talking about a quarter of a degree per minute. It's a very, very slow rotation. When people say the Earth is spinning, they're actually using the word spinning wrong, because by definition, spinning is rotating quickly. The Earth doesn't rotate quickly. Now, yes, that's a common usage, and you could call it a colloquial in that sense, but it's a common misusage if you go by the standard definition of the word spinning in any other context. That's the only context in which it gets used commonly that way. So, as a linguist, I would call that wrong. Um, there's not really a lot in language that I would call wrong, because it's very subjective. We each have our own views on what's right and what's wrong, what should be, what shouldn't be, how much something should be, how much something shouldn't be. I, for example, am not real fond of exceptions, and if, for example, the most common way to say a particular word is to drop a letter that's in the spelling, or to pronounce it as if it has a silent letter. Um, but if if pronouncing that letter is also something that's quite recognizable, um, I would generally prefer to go ahead and pronounce that letter. And if it's in slightly less common use, to pronounce the letter, but it's still somewhat common use, that would be generally my preferred one. So words like talk, for example, TALK, I barely pronounce the L. Walk, talk. Uh, Sometimes I don't pronounce it at all. Sometimes I barely pronounce it, but I usually leave at least a little hint of it in there. Whereas some people will say you should never pronounce that at all. It should be completely dropped out. A matter of opinion. So, but at any rate, yeah, my my opinion, my use of the word spinning, my understanding of the English word spinning, I would say no, the Earth is not spinning. The Earth is rotating. Um, it has a rotation of 1 degree every 4 seconds. The surface at the equator goes roughly 1,000 miles an hour. That's not a real accurate number there, but it works for doing ballpark figure calculations. And yeah, that 1,000 miles an hour, that sounds really fast to some people, but the thing is, you're talking about something that's thousands of miles around, and thousands of miles in diameter, radius for that matter. It's big, and um, so yeah, that 1,000 miles an hour isn't enough to throw stuff off the planet. If it was, it would throw pieces of the planet off the planet. Because the only thing that's holding stuff on the planet, of course, is gravity. Well, I shouldn't say the only thing. There's a little bit of effect of electromagnetism in there. Of course, that's what's holding together the individual particles, the individual pieces of stuff that are on the planet. But to keep it all in one place, that's basically all gravity. In the Earth's atmosphere. Um, some people say, "Oh, flat earthers." They say, "Well, if the Earth was a sphere um, up there in outer space, in the vacuum of space," some of them think space is imaginary. If the Earth was in the vacuum of space, it would lose all of its atmosphere, because you can't have a pressurized atmosphere in a vacuum. Well, that would make sense, if not for Earth's gravity. So just imagine this for a moment. Just think about, let's say you had a planet that had gravity, and it had an atmosphere, and it was in a vacuum, and so its atmosphere got sucked out into the vacuum. Now vacuums don't really suck. That's a physics issue there. But just going with the usual way of looking at things and saying, okay, atmosphere is sucked out into the vacuum. Well, what's going to hold it there? I mean, once it's out there, after all, you then have a vacuum on the planet. And now you have an atmosphere that's out there away from the planet and weighs something. Gravity's going to pull it back. And this is exactly what happens. At the fringes of the atmosphere, the Earth is constantly losing and regaining atmosphere. There's always particles of atmosphere escaping and getting pulled back by gravity, and other ones escaping and getting pulled back by gravity. Those that have enough energy to reach an escape velocity, if they can get going fast enough, they won't come back. But then there's other particles in space that fall down to Earth because they happen to end up in the right vicinity to do that, and the Earth is actually gaining a tiny little bit of weight each year. Well, tiny in comparison to its actual size, as a result of that, of particles falling in from outer space. So it's gaining more than it's losing. Um, but yeah, it does lose some that way. Any rate, that should be good enough for my International Space Station sunrise video. I hope I've made it somewhat interesting, and if not, well, then I hope people were smart enough to just turn the volume off and enjoy the view. Thanks for watching.